Casting is used to shape materials into useful products. Specifically, casting is used to make the desired material take the shape of the mold used to cast it. Casting is used to create an incredibly wide variety of items, from machine parts to action figures to even ant colonies. The shape of the final product is dependent on the shape of the mold, which allows for a large degree of freedom for the shapes that can be made through casting. Casting is often reserved to create complex shapes that would be extremely difficult to machine conventionally. Typically, molten alloys are used in casting, although curable nonmetals such as resin, clay, or concrete may also be casted. Molten metals fall into two general categories: ferrous or non-ferrous alloys. The metals are chosen carefully, considered based on their machinability, weldability, and several other factors for processing and project considerations. Cooling temperatures need to be considered based on the material used. Pure metals can be cooled reliably at constant temperatures. However, alloys are more complex and may require temperature variations in cooling. There is also a potential need for heat treatments and other refining processes after casting. The total cost depends on several factors, including the materials used, the molds and dies used, the total amount of labor, and all the equipment involved in the casting process. In many cases, casting is a better alternative than machining. The two main methods of casting are expendable mold and permanent mold casting. Expendable mold casting is relatively cheap, requiring less equipment costs than permanent mold casting, but is generally less precise. The time required in the mold casting process is heavily dependent on the materials used, the geometry of the casted item, the casting processes, and a multitude of other factors.
Machining is a manufacturing process of removing material from a workpiece. The primary forms of machining are turning, drilling, and milling. Turning is a technique in which a product is placed on a shaft and spun at high frequencies, allowing for material to be cut away from its surface. This process can be carried out manually or automatically using a lathe. A turret lathe is most commonly used in mass production as it is designed to repeat the same controlled cuts from a workpiece. Less expensive special-purpose lathes also exist for smaller-scale use by hobbyists or workers. Drilling is a common form of machining in which a drill bit is used to remove a circular cross-section of material. The material can range anywhere from solid rock to plywood, resulting in a large variety of drill sizes and drill bit strengths. Inexpensive hand-operated power drills are designed for domestic use, while massive diamond core drilling rigs are made to cut as deep as 1,500 meters into the earth. Laser drilling is another form of machining which is used for high-precision applications, allowing holes to be cut at 1,000th of an inch in diameter. Another form of machining is milling, the process of removing material by feeding a workpiece into a rotary blade. This occurs from the blade performing many high-speed repeated cuts into the workpiece. A cheap milling cutter would have a blade made of steel and spun at a very high speed. Cemented carbide blades are more expensive, yet leave a smoother surface finish, work faster, and can cut through very tough materials. Besides milling, turning, and drilling, there are many other machining techniques widely used in manufacturing that have allowed industries to become even more precise in their design process.
Forming is a type of manufacturing process that is used widely throughout industry. Forming processes are particular manufacturing processes which make use of suitable stresses such as compression, tension, shear, or combined stresses. These applied stresses cause plastic deformation of materials to produce the required shapes. During forming processes, no material is removed, they are only deformed and displaced. Some of the major examples of forming processes include forging, extrusion, rolling, and sheet metal working. Of the most popular on the list is sheet metal working, which is seen here, where a thin metal bracket is pressed over a metal slab to create the desired design. As you can see, this process is extremely proficient at producing the product at a fast rate with minimal outside contact coming into place. Another popular practice of the forming process is extrusion. This process involves heating a billet, which is then placed behind a heated die. This billet is then pushed through the die and extruded out to the other side, which is where it goes through a cooling process. Once properly cooled, the material is stretched and cut to desired length, where it can be stacked and cured in a furnace. After the curing process is complete, these extruded profiles are ready to start the following process.
Joining is a manufacturing process in which two individual parts are linked together to form a single connection between them. The area where this linkage occurs is commonly referred to as a joint, which can be formed by a variety of methods such as welding, brazing, and soldering. Welding is a joining process that involves the use of high temperatures or pressures to fuse two metallic components together. Shielded metal arc welding is one of the most common types of electrical welding, where a current is formed between an electrode and the base material, heating and fusing a filler material to the point of contact between the two pieces of the metal. This method of welding is usually performed manually and with the necessary skills has the advantage of lower costs, portability, and flexibility with joining smaller parts together. Another process, known as metal inert gas or MIG welding, is better suited for applications in mass manufacturing. Though significantly more expensive, MIG welding is a high-efficiency process that is usually performed by automated machinery. Another prominent joining method is brazing. Similar to welding, brazing requires an input of heat, yet instead of melting the surface of each component, a filler material is melted and then distributed in between the two parts. Because this process uses a lower temperature, it is better suited when it comes to joining parts of varying compositions. The filler metals that are used for brazing typically have a melting point higher than 450 degrees Celsius. If the melting point is less than this temperature, the process is then known as soldering. Soldering is mostly used in industries producing smaller scale components, such as circuit boards and jewelry. Precision is key when it comes to joining electronic parts, which is why the filler alloy most commonly used in this industry has a specific composition of 63% tin and 37% lead. Besides welding, brazing, and soldering, there are many other techniques used for joining materials. This includes adhesive bonding and the various forms of mechanical assembly, processes that all have their own unique benefits for today's industrial applications.
Finishing is any operation that alters the surface of workpiece to achieve a certain desired property. Typically, finishing is performed after the part has been formed. Without metal finishing, products comprised of metal would only last a fraction of their present lifespan because of corrosion and wear. It can also be used to enhance electrical properties, brightness of color, torque tolerance, get rid of burrs, or to make the part more aesthetically appealing. There are many different ways to perform a finish on a material. A few common ones are being shown in the video right now. Electroplating is passing an electric current through a solution containing dissolved metal ion and the metal object. The object becomes the cathode in the electrochemical cell and attracts the dissolved metal ions, plating it uniformly. Various metals can be used, including aluminum, brass, bronze, cadmium, zinc, etc. Case hardening, which is being shown right now, is when the object is heated and molded and then the temperature is quickly dropped or quenched, creating a much harder outer surface protecting the metal underneath. Cladding, which will be shown shortly, is where the metal coating is bonded to the object by combining heat and pressure. It is used to deposit a thicker coating than electroplating, but equipment costs are much higher in this process. Each process requires different equipment to perform. Electroplating typically operates in a series of baths containing various chemicals to achieve the desired characteristics, while case hardening sometimes requires massive stoves and baths to quench the materials being used. Finishing can get quite expensive when manufacturing a product when you take into consideration the equipment, material, and labor costs. Not to mention, it adds another whole section the part needs to go through, making it time consuming. And everyone knows that time is money in the manufacturing world.